Hello students, welcome to Bitsat forum. This is Brahma, your reasoning faculty. So today we will continue our previous chapter, that is logical deductions chapter. And before going to the questions, before going to solve these questions, and before just let us revise the concept once again. And this is the concept we have seen in the previous class, right? So question is in this format. Some statements will be given and followed by some conclusions, and we have to process all the statements combinedly, and from that result we have to verify the conclusions, each and every conclusion individually, separately, right? And how to say whether the given conclusion follows or not follows. If a conclusion is satisfying all the possibilities after combining all the statements, all the possibilities, then we can say it is follows. If it is fail in at least one possibility, then we have to say it is a fail only. Okay, it is not a definite conclusion. Next, coming to the statement format, all cats are dogs. We have taken one example. All cats are dogs. All is the qualifier, subject, object, and predicate. Object or predicate, and this is just a linking word. So here our concentration is not on the subject or predicate or linking word. Completely we have to be perfect with the qualifier only. So basically there are 4 qualifiers, all, some, no, and some not. And here is the positive qualifier and negative qualifier and universal qualifier and particular qualifier. Next, when the diagram is given, then how to identify the conclusions, how to say the conclusions. In this way we can say, and wherever sum is true, sum is the subset of all, that means all is true, then sum will be true automatically. Similarly, sum not is the subset of no, that means no is true. In that particular case, sum not will be true automatically. Next, how to draw the diagrams for the statements. Okay, when the statements are given, how to draw the diagrams in this way. And every time we don't need to draw these many diagrams for each and every statement. We will draw only one diagram. What is the diagram? That is called basic diagram. And we have 2 types of diagrams. One is basic diagram, other is alternate diagram. Basic diagram is the compulsory diagram for each and every question we have to draw. Alternate diagram, that is optional. Okay, as the name itself. Alternately we will use if required we will use. If the situation comes, we will use that one. Otherwise we don't need to use alternate case. Okay, I'll show where the situation comes also. So this much only in the last class. Once again watch that previous class and come to this class now. Today we are going to solve the questions. Let me show one example question. Suppose there are some statements like number 1, all A are B. Next, some B are C. These are the 2 statements given. And conclusions, number 1, all A are C. Second, some A are C. These are the 2 conclusions given. Tell me which conclusion follows the given statements. Which conclusion is satisfying the given statements. Okay, what we have mentioned in the concepts, we have to draw the common Venn diagram. Common Venn diagram for the given set of statements. Let me draw the common Venn diagram here. All A are B. Which diagram we need to draw? We have to draw the basic diagram only, not the alternate diagram. Alternate diagram, anytime we don't need to draw. We just extend our concept of basic diagram, okay, to disqualify that conclusion. Okay, if we are able to disqualify the conclusion, then that will be false. If we are unable to disqualify the conclusion, then we have to accept it is true. So all A's are B's. This is the basic diagram we have. Next, some B are C. Some B are C. Can I draw in this way? Yes, this is also a possible diagram. See, this is also a possible diagram. And even if you draw in this way, no statement is getting disturbed. All A are B, yes, that is true for this diagram. Some B are C, that is also true for this diagram. But this is not the basic diagram. Okay, what is the rule for basic diagram? Basic diagram rule is we have to intersect the circles as minimum as possible. That means without mentioning in the statements, we cannot cut any circle unnecessarily. If required, you can intersect the other circles also. But it is not mandatory, it is not necessary to intersect the circles as per the basic diagram rule. Okay, so this is the basic diagram for the given set of statements. Some B are C. So this is the basic diagram. Now verify the conclusions one by one. All A are C. Is complete A is inside C? No, that means it is fail. Second, some A are C. Some part of A, is it intersected with C? That is also no. So that means here our answer is neither conclusion 1 nor 2 is true. Okay, neither conclusion 1 nor 2 is true. Let me show one more example here. Statements are some A are B. Next, no B is C. No B is C. So these are the two statements we have, and conclusions are all A are C. Second, no A is C. Okay, so two statement and two conclusions are given. So let us draw the basic diagram first. That is, some A are B, some part of A is B, and then no B is C. So simply no B is C means B and C should be separate circles. But simply drawing in this way it is not sufficient to conclude the conclusions, because C is having negative, means this no is for what? For which two parameters? So for these two circles only. The constraint no is between B and C only. There is a restriction between B and C only. So B should never intersect, or C should never intersect with B in any situation or in any possibility. That means it doesn't mean C should not intersect with A also, right? So C can intersect with A if required. Okay, if required, and if there is a possibility, C can intersect with A, but C should never intersect with B in any possibility. As per the statements, we have to completely stick to the statements only. So we should not go beyond the statements. We should not violate the statements. Without violating the statement, you can do anything in this chapter. Okay, without violating the statements, you can do anything in this chapter. So C, if C intersect with A in this way, instead of drawing C there, what if I have drawn C like this? Is there any intersection between B and C? No intersection between B and C. And some A or B, that is also true. Is there any disturbance in the statement? There is no disturbance in the statements, right? That means this is also one of the possible diagram, but this is not the basic diagram. Then what we call this diagram? One of the alternate diagrams. Okay, there is only one basic diagram for each and every qualifier, but there may be many number of alternate diagrams for each and every qualifier. So we don't decide the answer based on the alternate diagram. We have to draw the basic diagram only initially. So I'll tell when the situation comes. Okay, in this question only, where to use alternate diagram also I will give clarity. Okay, see, all A are C. Is complete A inside C? No, that means it is fail. Next, no A is C. So there is no intersection between A and C. Is this correct? Is there any intersection between A and C? No intersection. He is also telling the same thing. That's why it is true. Yes? No, it is not true. See, in this possibility, in this basic diagram, there is no intersection between A and C. But in one of the possibilities, if you keep on drawing the alternate diagrams, in one of the possibility, we may get this one as the diagram, right? This one as the possible diagram, one of the alternate diagram. So in this case, in this possibility, A and C intersected or not? Yes, intersected. In that possibility, is this true? No A is C, is it true? No, it is not true. It is fail. So one possibility fail means total it will be fail only. It is not a definite conclusion. It may be a possible conclusion. Okay, we will see possibilities also. It may be a possible conclusion, but it cannot be a definite conclusion, because basic diagram is true, but alternate diagram fail. Somewhere it has failed, because A and C can intersect. Whenever they intersect, then this will be fail. But why we have not verified this one, sir, alternate diagram for this? Because it is a positive qualifier. Positive qualifier, if basic diagram is true, in all the alternate diagrams it will be true automatically. Okay, no need to verify. In the basic diagram there exists some overlap, means in every possibility this overlap exists. In every possibility this overlap exists. Okay, it may be some overlap or it may be all. If it is mentioned in the statements only, there are some A's or B's. Some A's or B's means there exists some A's or B's in 100% possible cases. So that's why if for a positive conclusion, if basic diagram is true, let me write here, for a positive conclusion, basic diagram result is final. Okay, no need of AD. Okay, we don't need to consider AD. For a positive conclusion, basic diagram result is final. That means if basic diagram is true, it will be true 100%, and if basic diagram fail, so then what if basic diagram fail? Sir, basic diagram itself it is fail, then for what purpose we need to check alternate diagram? We need a failure case only. If one possibility fail, total fail only, na? Yes. So see the first question also, first example also. Basic diagram itself it is true, then no need to verify alternate diagram. Sorry, fail, no need to verify alternate diagram. Here also, basic diagram itself it is failed, then no need to verify alternate diagram. But for a positive conclusion, if basic diagram is true also, no need to verify alternate diagram, because everywhere it will be true only. So then when we have to consider alternate diagram, let me show here. AD comes into picture only when a negative conclusion, only when a negative conclusion BD is true. Okay, only when a negative conclusion basic diagram is true, then we have to consider alternate diagram to search for its a failure case. If there exists a failure case, then we can say it is failed, right? If we don't get that failure case, then we have to accept it is true. So hope you are clear with these two examples, and no need to worry if it is not understood also, because we are solving the questions in from the next slide onwards, and while solving the questions also you can observe how I am solving and how I am taking the conclusions. Okay, see options are given here. You have to pick option. See here it is mentioned in the data, it is mentioned that you have to take the given statement to be true even if they seem to be variance with the commonly known facts. Okay, you have to consider them as true and then decide which of the given conclusions logically follows, right? Yes. See the first question. All cards are tables. All cards are tables. Next, all tables are trains. All tables are trains. Here be careful with the notation used. Tables I am using TB and trains I am using TR. Okay. Next, all trains are buses. All trains are buses. BS I am using, and CT I am using. So this is the basic diagram. Now verify the conclusions from this. All tables are buses. Tell me from the diagram, is complete table circle is inside a bus circle? Yes, it is, means true. Second, all trains are tables. Tell me from the diagram, complete train circle, is it inside table circle? No, that means it is fail. Okay, so answer for this question is option, only conclusion 1 is true, option A. Next question. Some mobiles are computers. Some mobiles are computers. Some computers are calculators. Be careful with the notation. CMP I'm taking. Mobile MOB I'm taking. Computers, calculators. Some computers are calculators. CAL I'm taking. Some calculators are phones. Some calculators are phones. This is the basic diagram. Okay. Verify the conclusions from this. First conclusion. Some phones are computers. Tell me, is there any direct overlap, direct intersection between phone circle and computer circle? Phone circle and computer circle, there is no direct overlapping. That means this is fail. Next, some computers are mobile. Some computers are mobile. Yes, there is a direct overlap because this is computer and this is mobile circle. And even from the statement itself, we can say this is true. Statement itself is a conclusion. It is always true because by considering statement true, we are concluding the conclusion. That's why. Okay, here the answer is only conclusion true, that is option B. Next one. All spoons are bowls. All spoons are bowls. Let me draw the diagram, basic diagram. All spoons are bowls. Some bowls are glasses. Some glasses are plates. Okay, this is the basic diagram. Now verify the conclusions one by one. Some glasses are spoons. Is there any direct intersection between glass circle and spoon circle? No, that means it is fail. Some plates are bowls. Some plates are bowls. Plate and bowl also there is no intersection. Plate is here and bowl is here. There is no intersection, fail. So you may ask us, sir, in alternate diagram, when we draw alternate diagrams, somewhere they may intersect, right? So yes, they may intersect, and if you keep on drawing the diagrams, possible diagrams, so your final diagram for this one will be S equal to B equal to G equal to P, right? Complete overlap, 100% overlap. This will be the last and final basic diagram, final alternate diagram you will be getting. Sir, in this diagram, if you see, these two are true conclusions, right? But still they are fail only because one possibility fail, total fail only. So in the basic diagram itself it is fail, means why to draw alternate diagram? So no need to draw any alternate diagram if the basic diagram itself it is fail. Okay, next, yeah, let me draw the diagram. Some envelopes are packets, some envelopes are packets, some packets are boxes, all boxes are parcels, all boxes are parcels. PRC I'm using, and packet PKT, and box BX. Next, envelope EN. Okay, so this is the basic diagram. From this diagram, verify the conclusions one by one. Some parcels are packets. Tell me, some parcel and packet, is there in direct overlap? Yes, there is a direct overlap between packet and parcel. Yes, it is true. Second, some parcels are boxes. Some parcels are boxes. So from the statements only we can say all boxes are parcels, means some parcels will be boxes. And in the class 1 of this one, in the introduction, in the concept class, before this class, I have told if all is true, in that case some will be automatically true, no need to verify. See, all boxes and parcels, see, in between parcel and boxes only it is given for sum. All is the superset and sum is the subset. If superset is true, then subset will be automatically true. So it is also true. Answer for this question is both conclusions 1 and 2, that is option E. Okay, next, draw the diagram. Some desks are tents, some desks are tents, some tents are rivers, all rivers are ponds. So this is pond. This is the basic diagram. Now verify the conclusions one by one. Some ponds are tents. Pond and tent, is there any direct overlap? Yes, there is a direct overlap. Next, some ponds are desks. Pond and desk, there is no intersection between D and P. That's why fail. So the answer for this question is only conclusion 1 is true, that is option A. Next one. Yeah. No book is box. There should be no intersection between book and box. This is book and this is box. In any possibility they should not intersect. Okay, why I'm drawing this way, why I'm drawing this way in between two circles? They should not intersect. In any possibility they should not intersect. Okay, to avoid that overlap I'm drawing in this way, I'm keeping them away. Yes, all boxes are pages. Complete box circle is inside page circle. This is page. Next, no cap is page. There should be no intersection between cap and page in any possibility again. They should never intersect. Tell me from the diagram, tell me, can cap intersect with book? Yes, it can intersect with book. Can cap intersect with box? No. Actually, yes, sir. Means a possibility is not there, but permission is there. As per the statements, there is no direct constraint between box and cap. They can intersect. If possible, they can intersect. But here possibility is not there, because cup cannot go inside of box and box cannot come outside of page. Okay. So that's why they cannot intersect. Cup and box can never intersect. Coming to the conclusions. No box is cap. Yes. For this one I have given the explanation just now only. No box is cup means it is true 100%. Always it is true, because they can never intersect. Okay. C cannot go inside, cup cannot go inside of page to intersect with box, or box cannot come outside of page to intersect with cup. That means they can never intersect. So whatever is mentioned here in this conclusion is true. Second, no page is book. No page is book. Here, no page is book in the basic diagram it is true, right? In the basic diagram it is okay. But I told one point. What is that point? When the alternate diagram comes into picture, yes, alternate diagram comes into picture only when the negative conclusion basic diagram is true, right? See, I think here only, yes. AD, alternate diagram comes into picture only when a negative conclusion is basic diagram true. Yes, this is a negative conclusion and basic diagram is true. Then we have to wait, search for its failure case in one of the alternate diagram. Tell me when it will be fail, when we can say this is not true. If there is an intersection between page and book, correct? So if page and book intersect, then we can say it is fail. Tell me, can page intersect with book? Yes, in somewhere, in some possibility, page can intersect with book, because even page, if it is intersected with book also, there is no disturbance in the statements. Without disturbing the statements, we can draw the diagram in any way, but that is not the alternate diagram. Okay, in alternate diagram, it is having a failure case. So one possibility fail means in this possibility it is fail, means totally it is fail only. One possibility fail, total fail. So then answer for this question is option A. Only conclusion 1 is true, because no page is book. But from the diagram we can say some pages can be books. So some pages can be books means somewhere they can intersect. In that possibility it is fail. All boards are desks. All boards are desks. Some desks are covers. Some desks are covers. No board is TV. There should be no intersection between board and TV in any possibility. Okay, they should not intersect. Tell me from the diagram, can TV intersect with D, desk? Yes, possible. Can TV intersect with C, covers? Yes, it is also possible. But can TV intersect with B? Never, because it is mentioned in the statement itself. They should not intersect. So finally, this is the basic diagram we have, and from this diagram we will verify the conclusions one by one. So first one, at least some desks are not TVs. At least some desks is same as some desks only, no? Okay, so whenever you see at least, you can ignore that at least, because at least itself is some only, and some is already mentioned adjacent, so that's why you can just ignore that. So see, some desks are not TVs. Tell me, is there any portion of D that cannot be placed inside a TV? Yes, this part of D cannot be placed inside a TV. So keeping in mind this part, some D is always exists. Some part of desk cannot be placed inside TV. It is true 100%. Okay, next one. Here also you can ignore at least. Some covers are not desks. Let me change the color of the pen. Some covers are not desks. Some covers are not desks. Tell me, is there any portion of C that cannot be placed inside C? No. Complete C can also be drawn inside D. Complete C can also be drawn inside D. Still there is no disturbance in the statements. Tell me when the statements will be disturbed. Only when B intersect with the TV. Board and TV, if they intersect, then only statements will be disturbed. Otherwise statements will not be disturbed. Here, if you draw C inside of D, there is no intersection between B and TV. So that means there is no disturbance in the statements. That means it is a possibility, right? So if all C can be D, all C can be D, this possibility exists. That means this is not a definite conclusion, because it is having a failure case. This is the failure case of this. Yes or no? Some covers are not desks, but all covers can be desks. No? Somewhere all covers can be desks means some covers are not desks is fail, right? So overall answer for this question is only conclusion 1 follows. Every question first you try and then see the solutions. Okay, yeah. Next one. All butter is curd. All butter is curd. All milk is butter. All milk is butter. No curd is water. No curd is water. There should be no intersection between curd and water. Yes. Coming to the conclusions. No butter is water. No butter is water. Yes, it is 100% true, because butter and water can never intersect, because it is kept inside of C and locked outside. Okay. B and M, butter and milk, kept inside of C and locked outside. That means water cannot intersect with B, butter and milk. So here no butter is water is true. Next, all milk is curd. Complete milk circle is inside curd circle. Yes, it is true. Yes. So overall the answer for this question is both A and B are true. Next one. Some threads are windows. Some threads are windows. All handles are threads. All handles are. Some doors are handles. Some doors are handles. This is handle. Okay. Some doors are handle. That's all. So these are the three statements given, and this is the basic diagram we have. Tell me, is there any negativity in the statements? Is there any negativity in the statements? No negativity. That means every circle can intersect with any other circle in any way in alternate diagrams. Okay. But this is the basic diagram. There is a rule for basic diagram, that is minimum overlap. That's why we got this diagram. Otherwise, you can draw the diagram in any way. But means every circle can intersect with any other circle in any way. So coming to the conclusions, at least ignore at least because some is already there. Some doors are not threads. Some doors are not threads. Tell me, from this diagram, all doors can be threads or not? Yes, all doors can be threads. If I keep complete D inside T, will there be any disturbance in the statements? No disturbance. That means that is a possibility. That means this is a possibility. This possibility is enough to say this is wrong, because complete D, all D's can be T's, but he is saying some D are not T, so that's why this is fail in that particular possibility. That means it is not a definite conclusion. Definite conclusion means it should satisfy 100%. Possible conclusion means it may be true at least once. Okay. Next one. At least some handles, ignore this one. Some handles are windows. Some handles are windows. Yes. So tell me, in this possibility, in this basic diagram, is there any overlap between handle and window? No, there is no overlap, but he is saying some handles are windows. So it is also not 100% true. It is also not a definite conclusion. So answer is neither conclusion 1 nor 2 is true. Option D. Next one. Some groups are villages. Let me draw the diagram. Some groups are villages. Next. No forest is a city. We cannot draw this one because the existing words are not available. Going to the next statement. Some cities are groups. Some cities are groups. Now coming to the previous statement. No forest is a city. There should be no intersection between forest and city in any possibility, right? So this is the basic diagram. Tell me, from this diagram, can F intersect with the C? No, F can never intersect with C. But can F intersect with G? Yes, possible. Can F intersect with V? Yes, possible. Can I draw complete F inside G? Possible? Yes, possible. Can I draw complete F inside V? Possible? Yes, that is also possible. Can I draw complete V inside F? That is also possible. Can I draw complete G inside F? No, that is not possible because of this region. Okay. Yes. Now verify the conclusions. At least some cities are villages. Some cities are villages. City and village, there is no direct intersection. Fail. Next. At least some groups are not forest. Ignore at least. Some groups are not forest. Tell me, is there any portion of group that cannot be placed inside forest? Yes. This portion of group cannot be placed inside F because it is intersecting with C. C should not intersect with B. But if I keep complete G inside F, then statements will be violated. So without violating the statements, we can do anything. So that means it is not, some groups are not forest. Yes, this part of group can never be forest. So keeping in mind this part, we can say this is true always. Always there exists some part of G that cannot be F. So answer only conclusion 2 is true. Next one. Yes, here more than 2 conclusions are given. Conclusion 1, 2 and 3. That's why options are given separately. Okay. Again the same approach. You try to solve the question first and then see the solution. All chairs are tables. All chairs are tables. Chair and table. All tables are telephones. All tables are telephones. TP I'm taking. All telephones are, sorry, that is also all only, no? Yeah, what is second statement? All tables are telephones. All tables are telephones. TP. Next. All telephones are cell phones. All telephones are cell phones. CP. No cell phone is computer. There should be no intersection between cell phone and computer. CMP I'm taking. And be careful with the notation when the same first letters are there. Table and telephone are having T as the first letter. So that's why you should be take a notation that is different from to identify both of them. And computer and cell phone also starting with the C. That's why here I have taken cell phone CP and computer CMP. Okay, right. This is the basic diagram. Let us verify conclusions. All cell phones are tables. All cell phones are tables. Complete cell phone circle is inside table circle, he is telling. No. Table circle is inside cell phone circle, but cell phone circle is not inside table circle. That's why fail. Second, some chairs are computers. Some chairs are computers. There is no intersection between chair and computer, and they cannot intersect also. So it is also fail. Next, no chair is computer. No chair is computer. It is always true. Correct? Because they can never intersect. In any possibility, they can never intersect. So that's why it is true always. So answer only conclusion 3 is true. Only conclusion 3 follows. Option C. Next one. Some rocks are hills. Some rocks are hills. Next. All mountains are rivers. So here all hills are mountains. All hills are mountains. And all mountains are rivers. Here already rock RK I am taking rock. And for river RV let us take. All mountains are rivers. Complete mountain circle should be inside a river circle. RV. Next, no river is canal. There should be no intersection between river and canal. CN I am taking. This is hill HL and MN mountain. So this is the basic diagram. Okay. Now verify the conclusions one by one. All rocks are rivers. Complete rock is inside a river circle. No, it is a possible. Sorry, it is a positive conclusion. Okay, positive definite conclusion. So basic diagram result is final result. So basic diagram is saying it is false because all rocks are not rivers here. That's why fail. Second, some hills are canal. Some hills are canal. Is there any intersection between hill and canal? No. So fail. Some rivers are canals. Some rivers are canals. So river and canal also. So from the statement itself we can say these two are controversial, right? Here it is saying no river is canal, but here it is saying some rivers are canals. So statement is true. That means conclusion it is fail. False only. So finally answer for this question is none follows. Next one. All rats are cats. All rats are cats. No cow is a cat. There should be no intersection between cow and cat. All dogs are cows. Complete dog circle inside cow circle. Okay. Now verify the conclusion. No dog is rat. There should be no intersection between dog and rat. Yes, it is correct 100% because dog and rat can never intersect because they have kept inside the circles and outside locked. Okay. Next, no dog is cat. No dog is cat. Dog and cat also cannot intersect, means it is true. No cow is rat. Cow is here and rat is here. They also cannot intersect. That means it is also true. So answer here is all follow. All follow. Okay. Next. Some walls are doors. Some walls are doors. Some walls are doors. Some doors are cots. Some cots are chairs. CT I am taking chair CH. CH. So this is the basic diagram. Verify the conclusions. Some chairs are doors. Some chairs are doors. There is no intersection between chair and door. Correct. So that's why it is fail. Second, some carts are walls. Cot and wall also there is no intersection. Fail. Third, no chair is door. See, is there any negativity in the statements? No, there is no negativity in the statements. So the negative conclusion fails, no? Because there is no negativity in the statements means every circle can intersect with any other circle in any way. So in intersecting in those many ways, somewhere every negative conclusion fails. This is also fail. Even if you see here, no chair is door, right? When it will be fail if chair and door intersect. So instead of drawing the diagram in that way, what if I have drawn the diagram in this way? One of the alternate diagram I am drawing. Here I am taking wall, door, cot and chair. So tell me, is it a possible diagram or not? Yes, this is one of the alternate diagram. Because even if you draw in this way also, there is no statement disturbed. Without disturbing the statement, we can draw the diagram in any way. So in this possibility, if you see, this no conclusion is fail, right? So answer for this question is none follows, right? But see, there is no option like none follows. So even if option E is given as none follows also, that cannot be the answer, because here one more additional concept, that is, see conclusion 1 and 3. Conclusion 1 and 3, if you observe, chair and door, here also chair and door, same pair of parameters, same pair of elements are there, right? So if same pair of elements are there, then we have to extend our concept like this. In basic diagram, let me check in this way, first and third. Basic diagram, first is fail, and alternate diagram, first is true. But in third, means no chair is door, basic diagram is true because there is no intersection between chair and door, right? But in alternate diagram it is fail because there is an intersection between chair and door. Because of this intersection, this is fail. So if you observe, wherever the first conclusion is false, then second conclusion will be true, and wherever the first conclusion true, in that case second conclusion will be fail. These two we can say complementary pairs. If one is true, other is fail, and if one is fail, then other will be true. Like tossing a coin, right? If we got head on the top, then tail will be wrong, right? If we got tail on the top, then head will be wrong. That means either tail may be the answer or head may be the answer. Similarly here also, either conclusion 1 may be the answer or conclusion 2 may be the answer, right? So answer for this question is either conclusion 1 or not 2, 3 here. For this question it is 3. Conclusion 1 or 3 is the answer. Only either 1 or 3 follows. So that means if you check all the existing possible diagrams, half of the diagrams with the first conclusion true and another half of the diagram with second conclusion true. So together will give you 100% diagrams, 100% possible cases. Half of the possibilities first is true, half of the possibilities second is true. And we should check all these things, we should do all these things only when the same pair of elements are there. Okay, chair and door, same pair is there, that's why. Okay, so for this let me give some trick like this. For each and every question, do one thing. After verifying individual verification, individual conclusions, means one by one conclusion, you should check first. And after completion of all the conclusions checking, then check these 3 points. Point 1 is same pair of elements exist or not. Same pair of elements must be there. Second, both conclusions must be fail. So see here, first conclusion itself it is fail, second conclusion itself it is fail. Individually they are fail. Both conclusions must be fail separately. Okay, and third point is either sum plus no must be there to conclude either or. Either sum plus no must be there, and other is all plus sum not must be there. Okay, either sum plus no must be there or all plus sum not must be there. Then we can declare, if these 3 points are satisfied, then we can declare these 2 conclusions are either or. Okay, so why what about the third point? See, one must be positive and one must be negative. Let me explain here. All, sum, no, and sum not. All is positive and universal. Sum is positive and particular. No is negative and universal. And sum not is particular and sum not is negative. Sum not is negative and particular. So here the condition is one must be positive and one must be negative, and one must be particular and one must be universal. So these two coming under either or. Next, one must be positive and one must be negative, one must be universal and one must be particular. That's why these two comes into either or. So only these two either or pairs are there in total syllogism, right? So why not all and some? Because both positive. Why not all and no? Because both universal. Why not all and some not? Yes, they are. Next, sum and sum not. Why sum and sum not cannot be? Because both particular. Why not no and sum not? Because both negative. So both negative or both positive, and both universal, both particular cannot be either or. Okay. So after the completion of after checking the individual statement conclusions, then verify these 3 points. Okay, same pair of elements must be there and both must be failed individually, and sum plus no or all plus sum not must be there. Right. Next question. All books are leaves. All books are leaves. Some leaves are jungles. Some leaves are jungles. No jungle is box. This is book BK I'm taking. No jungle is box BX I'm taking. Right. Some jungles are boxes. Sorry, books. Some jungles are books. There is no intersection, fail. Positive definite conclusion. Okay. Next. No book is box. Some books can be boxes or not. Yes. Instead of drawing box here, what if I draw like this box? There is no intersection between box and jungle. So as long as there is no intersection between box and jungle, then there is no disturbance in the statements. See, without disturbing the statements, we can conclude. So that means here some books can be boxes. That's why this is fail. Okay. Next, some leaves are boxes. Some leaves are boxes. So here positive definite conclusion. Basic diagram result is the final result. This is the basic diagram. So answer for this question is, yeah. Before concluding our conclusion, we should check either or conditions. Na? Is there any same pair of elements? Jungle and books in the first, second, third, jungle and books are not there. Book and box, second also, books and box not there. So there is no same pair of element, then there is no need to check either or. So final answer is none follow. Next one. Yes. So see conclusions, these are possibility conclusions. Possibility conclusion, we don't need to check 100%. We don't need to prove 100%. Okay. We just need to prove one possibility exists or not. Given possibility exists or not, that's all. Okay, no need of alternate diagram. That means alternate diagram exists, then this is true. Its possibility exists means that is true. See, all green are vegetable. Still we will draw basic diagram only. All green are vegetable. Complete green circle is inside vegetable circle. Next, all bears are green. All bears are green. Next, some green are nuts. Some green are nuts. This is the basic diagram. Now verify the conclusions. All nuts are vegetables is a possibility. Complete nuts, can it be placed inside vegetable circle? Yes, possible. So that possibility exists or not? Exists. No need to check. It's a failure case, because actually it is a failure in basic diagram. But here it is a possibility or not? Yes, it is a possibility. In one of the alternate diagrams, there exists one diagram like this. Nut is inside, completely inside vegetable. That is a possibility. Next, some bears are nuts is a possibility. Some bears are nuts is also a possibility, right? Some bears can the circle bear intersect with nuts? Yes, it is a possibility. So answer for this question is both 1 and 2 are true. Both 1 and 2 are true. Next one. No book is shoe. There should be no intersection between book and shoe. Next, some shoes are stocks. Some shoe are stocks. ST. No stock is shirt. So SH already used. SHO I'm using for shoes, and SHI I will use for shirt. No stocks is shirt. There should be no intersection between stocks and shirt. SHI. So this is the basic diagram. Verify conclusions. Some books are shirts is a possibility. Some books are shirts. Yes. If book and shirt intersect, there is no disturbance in the statements, means it is a possibility. Next, some shirts are shoes is a possibility. Shirt is here and shoe is here. Shirt and shoe, can they intersect? Yes, they can intersect. That means it is a possibility. Statements will be disturbed only when book intersect with shoe or stocks intersect with shirt. Otherwise, everything is a possibility. So answer for this question is both 1 and 2 are true. Next one. All books are shops. All books are shops. Some houses are shops. Houses. Some houses are miracles. See, actually there is no negativity in the statement. So that means every positive possibility will be true. So it is a positive possibility. Yes, it is true. And it is also a positive possibility. It is also true. Because If there is no negativity in the statement, every circle can intersect with any other circle in any way. Okay, that means every positive possibility will be true. Actually, without drawing the diagram also we can say this. Right, next one. For the first time, some not in the statements, right? Some not in the statements. Some cups are not bowls. Some cups not bowls. Some not, what is the basic diagram? Two separate circles, right? But for no is also some the same diagram. So how to differentiate? See, some cups are not bowls. Take some part of cup, and this part can never come inside bolt, and remaining part of C can intersect with B, but this part can never coming under B. Next, all dusters are balls. This is bolt BO. All dusters are balls. We cannot keep it now. CU cup. All cups are balls. Right. This is balls. BA balls. Next, all dusters are balls. Complete duster circle is inside ball circle. DU I am taking. So this is the basic diagram, and verify the conclusions. Tell me first of all, when will the statements be disturbed? Statements will be disturbed only when this region, when you try to bring this region inside BO, then the statements will be disturbed. Otherwise, everything is a possibility. Tell me, all bowls or cups is a possibility? Yes. Complete bowls we can keep inside cups? Yes, that is a possibility. See, we can keep complete bolt inside cup CP because there exists this part. But we cannot keep complete cup inside bolt. This is not a possibility, but this is a possibility. So, sorry, here it is a definite conclusion, no? Because the word possibility is not mentioned here. That means it is a definite conclusion. For a definite conclusion, we don't stop with only one possibility. We should check it 100%. All bolts are cups. The basic diagram itself, it is fail, because all bolts are cups is not there in the basic diagram. One possibility fail, total fail. Suppose what if I have given one more conclusion like this, third conclusion, all bolts are cups is a possibility, then it is true. Okay, next, because it is a possibility, about a possibility, not definite. Second is, some dusters are cups is a possibility. Some dusters are cups, yes, cup and duster can intersect somewhere, is a possibility. So answer for this question is only conclusion 2 is true. Next one, all horses are cows. All horses are cows. Some cows are sheep. Some cows are sheep. All oxen are horses. This is oxen circle. Okay, that's all. And here also, for this one, definite conclusion we have to draw. But this one we can say directly it is true, because there is no negativity in the statements. All the statements are positive and it is a positive possibility. That means it is true. Okay. Second, that means first conclusion. For that purpose, we have drawn the diagram. Some oxen are sheep. Some oxen are sheep. No, there is no intersection. Fail. Okay. So watch this video. Before this video, watch the concept video 2-3 times and then solve the questions on your own, and then watch this video again. Then you will get clarity. I hope in one class you may not get this one. Okay. Repeat the video once and twice or thrice until you get it. So practice more and more number of questions. We'll meet in the next session. Bye.